Hey there, how's it going everybody? In this video, I wanted to go over iterables and iterators. Now there's a lot of confusion around these terms and exactly what they mean. And I definitely understand the confusion because it's also something that took me a while to understand. So take a list for example. So a list is iterable, but it is not an iterator. So that can sound a little confusing, but hopefully after you watch this video, you'll understand exactly what these terms mean and how to determine when something is iterable and when something is an iterator. And we're also going to learn how to make an object ourselves that is both an iterable and an iterator. Now, this video isn't only about understanding these definitions, it's also about understanding the concepts of iterators so that we can write better code. So understanding these underlying concepts is going to help you write code that is more efficient and will also help you see solutions to certain problems in a way that you might not have thought of before. So with that said, let's go ahead and get started. So to start off, let's first talk about iterables. Now, what does it mean if something is iterable? Well, on a higher level, it simply means that it is something that can be looped over. So for example, a list is iterable because we can loop over a list. Now, I know this might seem pretty basic right now, but just stick with me and we'll get to some lower level concepts in just a second. But for now, let's see what this looks like. So I'm going to create a simple list and with a few items and then loop over it. So I'll say nums is equal to, and we'll just set this equal to 1, 2, 3. And now let's loop over this. So on the next line here, I'll say for num in nums, and then we'll just print out the number. So if I run that, then you can see that it loops through and we get the values 1, 2, 3. Now, loops aren't the only things that we can loop over. We can loop over tuples, dictionaries, strings, files, generators, and all kinds of different objects. So what's actually going on in the background there? How can we tell if something can be looped over or not? Or another way to ask this is, how can we tell if something is iterable? If something is iterable, then it needs to have a special method called double_iter. So let me write this out. That is double_iter. Now, if you've seen my series on object-oriented programming in Python, then you might know that these double_ methods are also called dunder methods or special methods, or also magic methods. So let's see if our list has this dunder iter method. So to look at the methods and attributes available to a specific object, we can simply pass that into the built-in dir function and print that out. So I'm going to comment out our for loop for now. And right below this, I'm going to print dir and pass in our list of nums. Okay, so this returns a good bit of stuff here. Let me make this a little larger so we can see all of these. Now, this returns a lot of methods and attributes, but if we look through here, then we can see that one of these methods is double_iter. So our list does have that dunder iter method. So basically, something can be looped over if it has that method. So what the for loop is doing in the background is calling iter on our object and returning an iterator that we can loop over. So that is why we call a list iterable. Okay, so that brings us to iterators. So I said that a list was iterable, but it's not an iterator. But if we run the dunder iter method on our list, then it will return an iterator. So what makes something an iterator? So an iterator is an object with a state so that it remembers where it is during iteration. Now, I know all of these terms might be running together, but I think this is all going to make sense when we see some examples. So like I said, an iterator has a state where it knows where it is during iteration. And iterators also know how to get their next value. They get their next value with a dunder next method. So if I look at my list methods here, then you'll see that there's no dunder next method in for our list. So our list doesn't have a state and it doesn't know how to get its next value. So therefore it isn't an iterator. So for example, if I try to print the next value of my list, so if I go up here and just say print next nums and run that, then this gives us an error. And we can see that the error that we get says type error list object is not an iterator. And by the way, when I pass an object into that next function like that, in the background, it's actually trying to run the dunder next method on that object. And we saw that our list doesn't have a dunder next method. So that's why it's telling us that our list object isn't an iterator and it's throwing an error there. Okay, but I did say that when we run our dunder iter method, that it returns an iterator for us. So let's try that. So let's manually run that iter method on our list and see what the returned iterator looks like. So above the for loop here, I'm just going to say I_nums, underscore nums is equal to nums dot double underscore iter. Okay, so now we have an iterator of our nums list. Now this is what the for loop gets for us in the background. So let's print this out. And let's also pass this into the dir function and see what methods and attributes are available to our iterator. So above here, I'm just going to cut this out, and right underneath here, I'm going to print out dir of I nums, and I'm also just going to print this out by itself as well. So let's just print out I nums and save that and run it. Okay, so we got some output here, but before we go over this, let me change one thing here real quick. So it's a bit ugly to run our dunder methods directly like this. So for most of these, there are functions that call these in the background for us. So just like I said that the next function calls the dunder next method, the iter function calls the dunder iter method in the background. So instead of doing it like we have here, we can instead just say iter of nums, and that will be the same thing. So if we rerun this, then we can see that we still get the same output, but we don't have to run that ugly dunder method. Okay, so now let's go over this. So we can see that when we printed out our iterator, that it tells us that this is a list iterator. And there are lots of dunder methods returned here, but the two that we want to focus on are dunder iter and dunder next. So we can see here that we have dunder iter method here, and this also has a dunder next method as well. Now you might think it's a little weird that this iterator has a dunder iter method because that's what we ran on our original list in order to get the iterator that we have now. But it has to have a dunder iter method because iterators are also iterable. But the difference is that this double underscore iter method returns the same object. So it just returns self. And we'll see an example of this in just a minute. Okay, so if we remember, when I ran next on our original list, it threw an error and said that our list wasn't an iterator. And that's because it didn't have the dunder next method. But our iterator that we just returned here does have a dunder next method. So we should be able to get the next value from this. So let me comment out these print statements here. And underneath this, let me print out, we'll just print out next, and we want to print out the next of the I underscore nums. So if we run that, then we can see that it prints out the next value of our list, which at this point is just the first item in the original list. Now remember, I said that an iterator is an object with a state so that it remembers where it is during iteration. So if we run next on this again, then it should remember where it left off and print the next value. So let's go ahead and try that. So I'm going to copy and paste this a couple of times. So we have 3 print statements here now, and let me run this. So we can see that each time we printed the next value, it remembered where it left off, and the next method pointed to the next value in the iterator. Okay, so right now we've printed all of the items in our original list. The original list only has 1, 2, and 3. So what happens if we print one more time? So let me just paste in another one down here and save this and run it. So we can see that when we ran that one more time, we got an error. So it threw a stop iteration exception. Now that's expected. So if we run out of values, then it raises a stop iteration exception. But that's what iterators are meant to do. So when we hit a stop iteration exception, it means that the iterator has been exhausted and has no more values. So we can see it when we run through them manually like this, but when we run a normal for loop, it knows how to handle the stop iteration exception and doesn't show it to us. So in the background, a for loop is basically doing something like this. It's first getting an iterator of our original object, like we've done here on line 4, and then it's getting the next values until it hits a stop iteration exception. So basically, it looks something like this. So let me remove all of these here. Basically, it's doing something like while true, and then inside here, try to get a next item. So we'll say item equals next I underscore nums, and then we'll just print that item for now. Now, we also need to check for an exception. So we'll say except stop iteration. And if we get a stop iteration, then we will simply break out of the while loop. So now if I run this code, then we can see that we basically got the same result from before when we ran our simple for loop. Now, another characteristic of iterators that I should have mentioned is that they can only go forward. So there's no going backwards, resetting it, or making a copy of it. You can only go forward by calling next. If you need to start from scratch, then you can simply create a new iterator object from scratch and just start that over. Okay, so why does any of this really matter? So what are the practical examples of knowing this? Well, one example is that we can add these methods to our own classes and make them iterable as well. So let's see an example. So let's create a class that basically behaves like the built-in range function. So I'm just going to overwrite everything here, and I will close out of the output. And now we're going to create a class that basically behaves like the built-in range function. So I'll say class my range. Okay, so at this point, I should mention that we're going to get into some object-oriented concepts by creating classes, and I do have a series on object-oriented programming in Python if any of you are interested. Now, I cover a lot in that series that I'm not going to go into detail about here, such as the init method and instance attributes and things like that. So if this part is confusing to you in any way, then you can watch that series to get a better understanding of what we're doing here. Okay, so if we're going to make our own range class that behaves like the built-in range, then we need a starting point and an endpoint. So in our init method, so I'll say def double underscore init. So first we want to pass in self, which will be the instance, and then start and then end, so that we have a start point and an endpoint. And within the init method, I'll say self.value is equal to the start, and self.end is equal to the end. Okay, so now we want to make this class iterable. Now remember, for something to be iterable, it needs to have a dunder_iter method. So let's go ahead and add that. So we will add a method here of double underscore iter, and that will take in self. Okay, so at this point, if we remember, our iter method has to return an iterator. And by that, I mean that it has to return an object that has a dunder next method. But we can simply create a dunder next method within this class itself. And if we do that, then we can simply return this same object from our iter method. So we can just simply say return self. Now, this object that it's returning here needs to have a dunder next method. So since it's returning itself, it means that we need to add our dunder next method to this class. So let's go ahead and do that. So we'll say def double underscore next, and we will take in self. Okay, and at this point, we need to figure out the logic in order for the iterator to step through the values. Now, if you remember, I said that iterators have a state, and remember where they left off in the iteration. And if they're out of values, then it raises a stop iteration exception. So first, let's put in our check to see if there are any more values, because we don't want to do anything if we're already at the end. So let's go ahead and say if self.value is greater than or equal to self.end, then we will simply raise a stop iteration. Okay, so if our value isn't greater than or equal to the end value, then we can just continue on. So now we can say that the current value is equal to self.value. And then we want to increment self.value so that we are actually looping through something. So I'll say self.value plus equals 1. And now we can just return that current value that we first grabbed. Okay, so each time we run this next method, it will come in and get the current value, increment the old value by 1, and then return current. So now this should work as an iterator. So to use this, let's just go ahead and create one of these objects. So I'll say nums is equal to my range, and we will pass in a start value of 1 and an end value of 10. So now, let me scroll down here a little bit. Now let's loop through this. So I'll say for num in nums, print out num. So if I save that and run it, then we can see that it looped through the values 1 through 10. Okay, so this class that we created is iterable because we can use it in a for loop, but it's also an iterator because it has a dunder next method. So we should be able to call next on it manually to get the values one at a time. So instead of our for loop, let me just overwrite this, and instead let's just print out next of nums. So if I save that and run it, then you can see that we just get the first value. And let me do this a few more times here and save that and run it. And you can see that it loops through the next values. Now, if we were to continue on printing those out, then eventually we'd hit the stop iteration exception. Okay, so we're just about finished up with this video, but there's one more thing that I want to show you about iterators. So some of you may have used generators. Now, they're extremely useful for creating easy to read iterators. They look a lot like normal functions, but instead of returning a result, they instead yield a value. And when they yield a value, it keeps that state until the generator is run again and yields the next value. So generators are iterators as well, but the dunder iter and dunder next methods are created automatically. So we don't have to create them like we did in our class. So with that said, let me write a generator function that does the exact same thing that our range class does. So to do this, we can simply come under the class here, and we can create a generator function by saying def, and I'll just call this my_range. And again, we want a start and an end argument. Now, this isn't a class, so we don't need self here because we're not going to be working with specific instances. So all we need are start and end parameters. Okay, and at the beginning here, we can just say current is equal to the start value that we pass in. And now we'll just say while current is less than end, then we want to yield the current value. And then after we yield, then we'll say current plus equals 1 and save that. Okay, so now let's use this generator instead of our class and see if we get the same result. And then I'll walk through this one more time just to point out exactly what's going on here. So if I replace that and run it, then you can see that we get the same result. Okay, so let's think about what's going on here. So when we create this, it comes into this function here with a start value of 1 and an end value of 10. And then it sets current equal to start, which means that current would be equal to 1. And then we're saying while the current is less than end, then we want to yield the current value. So the first time through, it'll say while 1 is less than 10, which it is. So it'll come in here and yield 1. And then it will increment that by 1. And now we're still in this while loop. So now current will be equal to 2 since it incremented by 1. And it says, okay, is 2 less than 10? Yes. So yield the next value and then increment by 1. Is 3 less than 10? Yes. So yield that. And it'll keep doing that until it breaks out of this while loop. And whenever it breaks out of that while loop, then it hits that stop iteration exception. So just like with our class, we should be able to loop through this all the way using a for loop as well. So if I say for num in nums and then print num, if I save that and run it, then you can see that it prints out the values 1 through 10. So this generator function works just like the class does that we created, but I just think it's much more readable than the class. So I like to use these generator functions whenever I can. Okay, now the last thing that I want to say about iterators is that they don't actually need to end. So one of the cool things about iterators is that they can simply go on forever. So as long as there is a next value, then our iterator will keep getting each next value one at a time. So for example, if I were to remove our end variable here and then just put in a true statement for our while loop, so let me do that. So I'll just remove this end parameter, and then instead of putting in a conditional here, I'm just going to say while true. And now this generator no longer accepts an end value, so we can just pass in a start value. So I'm just going to remove the 10 and say that we want to start at 1. So now our generator iterator is going to simply go on forever. So since I'm looping through this with a for loop, it's actually going to get stuck in an infinite loop. And it's going to start printing from our start value, counting up by 1 forever. So I'll show you what this looks like, but I wouldn't recommend you do this on your machine because it's hard to stop it from executing and can freeze up your computer. But I'm going to try to run it and stop it quickly. So let me do this. So I'm just going to quickly run this and then stop it. Okay, so I was able to run that and then stop it by hitting Control-C on my machine. But even in that short time, it already counted up by a lot. So it counted up almost to 1 million values there. And that would have continued going indefinitely if I hadn't stopped it. Now, like I said, the iterator can go on forever, but it still only fetches one value at a time. Now, this really comes in handy when writing memory efficient programs because sometimes there are so many values that you just couldn't hold them all in memory if you were to put them in a list or a tuple. But if you simply use an iterator, then you can loop over one value at a time until it's exhausted or just let it keep going. So for example, let's say that you were writing a password cracker and wanted to brute force it by checking all of the possible passwords using a certain group of characters. Well, there would be so many different possible passwords that you couldn't possibly hold them all in a single list. Your computer would just run out of memory. But you could use an iterator to loop through all those possibilities one at a time. And it might take some time until you find a result, but your program wouldn't take up all of your computer's memory and it wouldn't crash. So maybe we'll write a program that cracks easy passwords in the near future so that you can see how something like that would work. Okay, so I think that we're just about ready to end the video, but let's do a quick recap of everything that we learned since some of this stuff can kind of run together. So what does it mean for something to be iterable? So broadly speaking, it means that it can be looped over, but more specifically, it means that the object needs to return an iterator object from its dunder iter method. And the iterator that is returned from dunder iter must define a dunder next method, which accesses elements in the container one at a time. So just because something is iterable doesn't mean that it is an iterator. And again, what does it mean for something to be an iterator? So that means that it's an object with a state so that it remembers where it's at during its iteration. And it knows how to fetch its next value using the dunder next method. And when it doesn't have a next value, then it raises a stop iteration exception. Now, I'm going to try something a little different with this video. So I've put together a coding problem to practice what we've learned in this video, and I'm going to release the problem and solution in a separate video shortly after this video is released. And I've had requests for a long time to come up with some problems where viewers could practice what they've learned. So I'm going to give that a shot and see if you all think that it's beneficial. Now, the reason that I'm going to release the coding problem in a separate video is because I want to keep the lessons and problems separate so that the lessons don't get too long. Also, if anyone wants to skip the problems altogether, then they can just simply skip the coding problem videos instead of trying to fast forward through parts of the lesson. So I'll leave a link to the coding problem for this video in the description section below if anyone would like to practice what we've learned here. But with that said, I think that's going to do it for this video. Hopefully now you have a clear understanding of what it means for something to be iterable and what it means for something to be an iterator. Now, we also learned how to add this functionality to our own classes, as well as writing generators with this functionality as well. Now that we've covered iterators, one of my next videos that I release is going to be on the itertools module and how that module provides some awesome tools for working with iterators. But if anyone has any questions about what we covered in this video, then feel free to ask in the comment section below and I'll do my best to answer those. And if you enjoy these tutorials and would like to support them, then there are several ways you can do that. The easiest way is to simply like the video and give it a thumbs up. And also it's a huge help to share these videos with anyone who you think would find them useful. And if you have the means, you can contribute through Patreon, and there's a link to that page in the description section below. Be sure to subscribe for future videos, and thank you all for watching.